Hello and welcome to the July edition. Hasn't time gone fast? Yes, I know that most probably thinking, well, we only heard the last show last week. Well, a few delays, but that's all fixed. So, as ever, welcome to CometWatch. It is a lovely, cloudy summer afternoon here in upstate New York, and I'll introduce our co-hosts. Hello, co-hosts. Are you still there?
Yep.
Hi, it's Mary Spicer here in a very cloudy Oxford.
And I'm Neil Norman in a very clear Suffolk.
And I'm Richard Miles in Dorset, deepest Dorset.
Welcome to the show, Richard. Okay, so as always, we are going to head over to the BAA Comics section page, and we'll give you the latest discoveries. It's all part of the shipping forecast, you know. Okay, so starting with June the 8th, Wochart Boomplod and Sizemon Li Wu report a Kreutzgroup comet in real-time C2 images.
Again on June the 8th, Warschat Bloomplod reports a Kreutzgroup comet in real-time C2 images.
On June the 11th, Warshot Boomplod reports a Kreutzgroup comet in real-time C2 images.
June the 11th, Bo Zhao reports a Kreutzgroup comet in real-time C2 images.
June the 11th, Zizmon Li Wu reports a Kreutzgroup comet in real-time C2 images.
June the 12th, Warshot Boomplod reports a Kreutzgroup comet in real-time C2 images.
June the 12th, Tygrave Pestergard reports a Kreutzgroup comet in real-time C3 images.
And on June the 14th, Trigrave Presgard reports a Kreutzgroup comet in real-time C2 images.
Again on June the 14th, Warshot Boomplod reports a Kreutzgroup comet in real-time C2 images.
June the 16th, Mikhail Kuske reports a Kreutzgroup comet in real-time C2 images.
And June the 17th, Warschat Bloomplod reports a Kreutzgroup comet in real-time C3 images.
June the 20th, Zijian Zhu reports a non-group comet in real-time C2 images.
June the 20th again, Alexandria Surev and Mikhail Kriskov report a Kreutzgroup comet in real-time C2 images.
And June the 23rd, Michael Kuziak reports a Kreutzgroup comet in real-time C2 images.
Again on June the 23rd, Bo Zhu reports a Kreutzgroup comet in real-time C3 images.
June 24th, discovery of 2016 M1 Pan-STARRS reported.
And on June the 25th, Warshot Bloomplod again reported a Kreutzgroup comet in real-time C3 images.
Again on the 25th of June, Zijian Zhu reports a Kreutzgroup comet in real-time C2 images.
June the 30th, Woodchuck Bloomplod reports a Kreutzgroup comet in real-time C2 images.
And July the 1st, Warshot Bloomplod reports a Kreutzgroup comet in real-time C3 images.
Again on July the 1st, Warshot Boomplod reported a Crack group comet in real-time C2 images.
July 2nd, Woodchuck Bloomplod and Sizemon Li Wu report a Kreutzgroup comet in real-time C2 images.
And on July the 3rd, Bo Zhu reports a Kreutzgroup comet in real-time C2 images.
On July the 3rd, the recovery of 2009 K1 periodic comet Gibbs as 2016 M2 was announced.
Again on July the 3rd, recovery of 2008 G3 periodic McNaught as 2016 N1 announced.
July the 4th, Warshot Bloomplod reports a Kreutzgroup comet in real-time C2 images.
And July the 5th, the recovery of 2008 T1 periodic Botini as 2016 N2 was announced.
And the website was updated on July 6th. Okay, on to current comet magnitudes and the observable region as of July 4th. So, I'm going to kick off with Pan-STARRS 2013 X1, magnitude 7. Fading is 35 degrees north to 90 degrees south. Visible all night. Last visual observation was July 2016.
Okay, then we have 81p Veiled, currently at magnitude 10 and steady, observable 30 degrees north to 35 degrees south. That's visible in the early evening, and the last visual observation was in July 2016.
Next is Pan-STARRS 2014 S2, an old friend of ours, magnitude 11.5 but fading now. 50 degrees north to 40 degrees south, best viewed in the early evening and last observed in July of this year.
226p Pigott Linear Kowalski, magnitude 12 question mark bright, 15 degrees north to 75 degrees south. It's a morning object not yet observed.
Then we have 9p Temple, which is currently magnitude 12 and steady, observable 45 degrees north to 65 degrees south. That is an evening object. Last reported visual observation was July 2016.
Next is Next is CometWatch 2011 KP36, magnitude 12.5 and steady, 45 degrees north to 60 degrees south. Best viewed in the morning, but has not been seen since September of 2015.
Next is Pan-STARRS 2014 W2, magnitude 12.5, fading 50 degrees north to 5 degrees north, all night, last seen in July 2016.
53p Van Biesbroek, currently at magnitude 13 and steady, observable 45 degrees north to 70 degrees south. That's best viewed in the morning. Last visual observation July 2016.
Next is Comet 237p Linear, magnitude 13 and steady, 35 degrees north to 70 degrees south, best seen in the evening and last observed in July 2016.
29p Schwarzmann-Wachmann, 13th magnitude question mark, varies 40 degrees north to 90 degrees south, best in the mornings, last seen 2015 October.
Then we have Comet Catalina 2013 US 10, currently at magnitude 13 and fading, is now at poor elongation. Last visual observation was May 2016.
Next we have our old friend Comet Lovejoy 2014 Q2, magnitude 13 question mark, currently fading 50 degrees north to 35 degrees south, best in the morning, and although it says October 2015 last seen here, an image was posted in CometWatch this week of it at magnitude 17.
And 116p Wild, magnitude 14, fading 30 degrees north to 75 degrees south, best in the evening, last seen in May 2016.
And finally, Pan-STARRS 2015 WZ, currently at magnitude 14 and fading. That's visible 50 degrees north to 5 degrees south. It's an all-night object. Last visual observation in June 2016.
And that is the current comet magnitudes and observable regions for this month. And now to our special guest, one of the BAA Comet Section's specialist observers. I think is probably the best way to describe you, Richard. We actually met at a BAA and Asteroid Section meeting about 2-3 years ago. And and now I'm going to turn the show over to you to tell us all about Schwarzmann-Wachmann.
Okay, thanks, Nick. Yeah, I think we met at Milton Keynes when we were doing the joint meeting between the Comet section and the Asteroid section of the BAA.
Yeah,
and
that was it.
we had a really good day, didn't we?
Oh yes, it was one of those rare occasions. It was really great. Some really wonderful presentations, and interestingly enough, some looks into the future, particularly with robotic exploration, and some ideas of what is really going on, particularly with comets and asteroids.
Yeah,
Certainly.
I was going to say the good thing was that we had a good mix of professionals and amateurs, more or less 50-50 of that one, and it helped us build our contacts with the professionals.
Exactly, and it's paying off today with the Packer group. So it is a good symbiosis, amateur observers and professionals. We have the equipment and the time, and they, I suppose in reality, they really wish they had the access to professional equipment to do what we can do. So
yeah, it's a really fast changing world for the amateur in astronomy, especially
Yeah.
moving objects like comets and asteroids.
Yeah.
And year on year, there are more and more people coming to the subject and contributing to what we call citizen science.
And let's face it, in some respects, the greatest kickstart our favourite hobby and subject has been given was the joint space agency's mission to Sheremenko. Oh, I can't say it.
Yurumov Gerasimenko.
Thank you, Richard. But that has really helped. It's put what we do into the limelight, particularly with the contributions that amateur astronomers make to science today.
Yeah, I remember back in the HalleyWatch, the international HalleyWatch era, back in '86. That's the previous century, of course, and it really we couldn't get going. It was such a struggle, you know. CCDs hadn't come into the hands of the amateur, and things really couldn't. We really couldn't do that much. But nowadays everything's different. I think a lot of it changed at the turn of the century when Herbert Robb wrote his Astrometrica software, and a lot of moving object people, call us that, started to use that to observe comets and asteroids, and things really kicked off then.
Yeah, even I've got a copy of it, and I have to get back into the habit of using it, and I need to relearn it. I think I'll go bug a certain Mr. House for that. It's his fault I got involved with Astrometrica, so he can bail me out and give me a few more lessons on it.
Yeah. So if we come back to the featured comet this month, 29P Schwarzmann-Wachmann, that's a real case in point, because when I look back at all the data, a lot of the data you see is reported to the Minor Planet Center. It's called that, but both asteroids and comets are reported there. And it was only in August 2002 that really people started to observe comets and measure their magnitudes with Astrometrica. And between then and now, which is about 14 years, there's well over 20,000, almost 30,000 observations being reported just on that one comet. So it has attracted a lot of attention, and it's only in the last 14 years that really we've started to be able to explore what it's actually doing.
Richard, could you give us a history of the comet?
Yeah, we've all heard of Halley's Comet, which is a periodic comet, and has been of major importance. But 29P was first discovered in 1927, and is really almost the opposite of what you might expect for a comet, which Halley is the archetypal comet. 29P is a comet. It has a coma, and what's unusual about it is that every now and again, every month or two, the coma seems to brighten. What this is, we think, is that the nucleus is extremely active, and unlike an ordinary periodic comet like Halley, it has small or large outbursts depending every few minutes, and it's really been an enigma up until recent times, because we really haven't understood what it's doing. So it was discovered in 1927, and the history is quite interesting, because just by chance there was a young student in university in the States called Fred Whipple. He was in his second year at uni, and the discovery was made by the two German astronomers, and they reported a comet that actually looked as though it was out beyond the planet Jupiter. And when Whipple followed this up as a student, he actually produced his first paper, his first sort of scientific contribution in 1928, early that year. And what it was is the orbital elements of this newly discovered comet. And unbelievably, it was in a virtually circular orbit between Jupiter and Saturn, which was like no other comet that had been seen up until that date. So even by those standards, then it was unusual because it occupied a very unusual place in the solar system. So that's really when things got moving.
Are there many comets that have such a circular orbit? Because we're used to seeing kind of orbital diagrams with those really steep elliptical patterns.
Yeah, that's a really good question. There's extremely few, in fact. All of the what we call the Jupiter family comets, they're all in the elliptical orbits virtually. Um, they've been moved there by the gravity of Jupiter and trapped. So their aphelion is near, almost as far as Jupiter is away from the Sun. There are what are called main belt comets, so-called main belt comets, but they're very, very weak activity, and they really look more like asteroids in terms of their orbits.
Right.
In terms of lookalikes of 29P, there's possibly one or two very small objects out there, but 29P is actually, when it's classed as a solar system object, it's actually not a Jupiter family comet at all, even though it's near Jupiter. It's actually a centaur.
Okay.
Centaurs are things which really have occupied the space between Jupiter and Neptune. So it's an object that we think has relatively recently moved in from the distant Kuiper belt, Edgeworth Kuiper belt. It's over the thousands of years, the gravity of the giant planets has gradually moved it closer and closer towards the Sun. It's sort of handed down from Neptune down to Uranus to Saturn. And now it's trapped effectively between Jupiter and Saturn. So that's where it's come from. And what's unusual is that it's obviously a fresh object, something that's arrived and has got lots of volatiles and lots of activity. So it's a sort of trans-Neptunian object, but one that's recently displaced and moved in much closer to the Earth. And so that's what also makes it interesting. Instead of having to launch a space probe to Pluto and beyond, what you can do is, if you study 29P, you're actually studying a representative of the trans-Neptunian object population. So it's a fascinating world out there.
Yeah, but one that's obviously a lot nearer than trans-Neptunian objects usually are.
Yeah, so the next thing to point out about it is it's actually big, just like trans-Neptunian objects. It's actually about 60 kilometers across, and that figure is fairly accurate, plus or minus 5 or 8 kilometers. It's really about the biggest periodic comet we know of, actually. It's slightly bigger than Comet Hale-Bopp was.
Wow.
Yeah. So that's, and it was of such interest to Fred Whipple that he sort of spent his career in comets. He's the guy that coined the term what was it?
Icy dirt ball.
Icy dirt ball he coined. And now we tend to call them dirty ice balls. Yeah, no, he called them, an icy...
Oh, sorry, he called them dirty snowballs, and now we know they're icy dirt balls. Is that
that's
right?
That's the one. That's the one. You got it spot on, actually. Yeah. And he wrote a few papers in the 1950s. He was trying to understand what comets were in general. He wasn't just 29P, but he was fascinated by comets full stop. And he wrote in the 1950s some of the early papers in trying to recognize what the nucleus is made of. Because although we see the comet's tail, the nucleus is tiny compared, tiny. It's only a fraction of a pixel in any telescope virtually that's used to image a comet. So Whipple, he actually came back to 29P latterly in his career. It was about 52 years later, when he was sort of approaching retirement. He tried to analyze all the observations that people had made up until 1977 to try to understand 29P, and he produced quite a nice paper in 1980. And it's surprising how many people had observed it over the years. They obviously didn't have CCDs, but they did have photography. And one or two other people were quite well known. Elizabeth Romer as well, who I think has recently died. She actually studied this comet in great detail. But unfortunately, Fred Whipple wasn't able to really solve the mystery of Comet 29P because he really didn't have enough observations to be able to elucidate what was going on. So there we go. That's the history, more or less.
I've read the stuff that you've written in the BAA about this comet, and it's just so fascinating. It'd be great for him to actually see some of these theories and just kind of get to grips with. I mean, it's just like the whole thing with the slow rotation and the cryovolcanism that's going on there, and it's all just such an interesting little thing, isn't it?
Yeah. Well, in the same sort of vein. I should declare my background here, and I haven't been, I'm an amateur astronomer, but I have to confess I'm a scientist by trade, and I studied at Bristol and did physical chemistry. I did 2 degrees there, and when I wrote my first paper in trying to understand comets, I was able to reference my supervisor, who unfortunately, Professor Everett, had died a few years before, and it would have been great, just as with Fred Whipple, to be able to go and see Professor Everett and say something that he'd written to do with chemistry all those years ago in the Proceedings of the Royal Society actually was relevant to what goes on beneath the surface of a comet nucleus. And,
yeah, he'd probably be thrilled with that, wouldn't he?
Yeah, it's just a shame can't live to over a century, and it's
yeah.
But yeah, I think as astronomers we're very well aware of the planet. Okay, so as I'm just confessing my background. So I was a research chemist working for the oil company Shell, and I would have loved to have been an astronomer, but back in the mid-70s, you couldn't really, not in the UK anyway, consider really being employed as an astronomer, being able to raise a family. You just had very few job opportunities. Whereas nowadays, of course, worldwide, it's quite a big topic, and men and women of all ethnic origins are free to study the subject and in fact to earn their living doing it. And the beauty about astronomy is that it's a common language that we all share. We all see the stars. And many of the things we do now, we require global observing campaigns, and we need people dotted around the world to be able to follow things like comets, to watch what they're doing. And I would encourage any young person to consider astronomy as a career. And the area that I've been particularly interested in is really, you could call astrochemistry. Because I did, as I said, I did chemistry at uni, and then I was a research scientist using what I'd learned. And what's happening now is, with all the modern advances in space technology, the Hubble Space Telescope, but more importantly, the infrared space telescopes like the Herschel Space Observatory, they're starting to give us information about the chemistry of what's going on out there. And
is that due to spectroscopy?
Yeah, exactly. Yeah, when we're limited to just the visible part of the spectrum, you're rather limited because you can't actually distinguish molecules. You can distinguish atoms; they emit in the visible. But if you want to understand, what's bouncing around out there in terms of molecules, you need to move well into the infrared, and in fact, right to the far infrared and the radio range of the spectrum. So the big radio telescope arrays, things like ALMA, are starting to produce a lot of information about chemistry, both in molecular cloud, but also in planetary atmospheres and in comets. And so, an expanding area for anyone interested in astronomy, maybe pursuing it as is astrochemistry, because that's going to be a growth area in the future.
It is. I mean, just looking at, how baffled people were when we saw those close-up pictures of Pluto last year. There's a whole kind of branch of, kind of astrovolcanism, astrobiology, astrochemistry that is just open for people to kind of go and develop skills and come up with theories. And it must be quite an exciting field to work in astronomy terms.
Yeah. I think partly it's a search for life, isn't it? It's trying to understand where we came from, and one of the hypotheses is that, and Fred Hoyle was involved, one of the well-known Cambridge astronomers from mid 20th century. The idea that comets actually seeded the building blocks of life by putting organic molecules onto planetary surfaces and into their atmosphere as comets collided with planets. And so, although it was rather poo-pooed at the time, now people are coming back full circle to think that indeed Fred Hoyle could very well be right, and many of the space probes, spacecraft that are being sent out are specifically very interested in the chemicals that may be found in certain regions of the solar system where the material may have been preserved, and a comet is one such object.
Yeah, particularly if it's one that's, like you say, a virgin comet that's only just coming in, it's carrying pristine material, then we must be able to learn a lot from it.
Well, Nick mentioned Comet 67P and the Rosetta probe, and one of the things about that is that the more that's learned, the more I realise that the actual surface of 67P isn't really pristine. As you might imagine, it's a Jupiter family comet. It's been pulled and injected into that orbit, and it's had many perihelion passages quite close to the Sun. And the heat of the Sun is just, and the solar wind, more importantly, just ages the surface. And volatiles are lost from the surface, and so we really don't have a pristine substrate below the surface to explore. And so there was a couple of meetings in London last month in June. There were 2 days of discussion meeting on Rosetta at the Royal Society that I attended, and then a further 2 days on where to next. That was one of the questions. It was we learned some more about Rosetta. This was held at University College London, and more importantly, last session was on where to next. And unfortunately, my offer to speak was accepted, and I gave a talk on suggesting that Comet 29P would be a really good target for the next cometary mission. So that's one of the things we've got to watch in future. And the more that amateurs can observe it, the more we can decipher what's going on, and the more I think people in NASA and ESA will take note of the fact that that particular object could very well be, as I said earlier, a representative of the trans-Neptunian region, and also a rather pristine, highly active nucleus. Yeah.
Mm.
I think.
So how much information can you actually get from an amateur image of comets?
Okay, yeah. Well, even a visual observation is useful if you're using quite a large telescope. If you can look for the position where the comet 29P should be, and if you have a negative observation, you can't see it, and say you can see down to magnitude 15. Then that's a useful observation, because we know that the comet was relatively faint and therefore couldn't have been in outburst at that point. So one of the purposes of observation is to try to, first of all, identify an outburst, but importantly, to try to actually isolate the exact moment in time when the outburst happened. Obviously,
Right.
you can't do that perfectly, but if we can narrow it down to half a day or even 5 or 6 hours, that helps in then analysing what's going on the nucleus itself. So observations to look for an outburst and then identify, to be first to see an outburst is actually quite a useful achievement by whoever it is that manages to do that.
No, it's useful because I know some amateurs that might be fairly new to this that might think, well, my little image isn't going to really be of much help to the pros, but everybody really should be submitting their findings because it does help. And
Yeah.
if anyone listening is kind of sitting on pictures or data that they're too shy to share, then I think they really should just submit it. If it's no good, it won't be used. It's better to have it and not use it than to have something useful in your house and no one know about it, I think.
That's right. You might not have done it in the first place anyway.
Yeah.
Although a lot of people do get a lot of personal satisfaction from having achieved something, and they don't necessarily want to broadcast that fact. But there again, if they're using a CCD or even a DSLR camera, they've got a permanent record, so they could share that with someone else, and that could be then checked to see, for example, whether 29p was starting its outburst or not. So a small telescope is still useful if you're checking whether it's having gone into outburst or not. So that's the first thing. If you've got a larger telescope, say 8-inch, 20 centimeter or bigger, and especially 30 centimeters and larger, then you can take some serious images of comets, especially 29p. Remember I said it's beyond Jupiter, so it's actually quite a distant object. It's normally about 6 AU, 6 astronomical units away from the Sun, and about 5 AU from the Earth at opposition. So it's quite a distant object, so you do need a medium-sized to large telescope if you want to start to actually measure the exact brightness of the comet. Because that's the second thing we do. Even though it's in quiescence most of the time, what we're doing now is we're following it as frequently as we can and measuring the brightness as accurately as we can. So we've got a standard procedure for doing that, and it's based on Astrometrica, which we mentioned earlier, that software for analysing what's called the FITS images that people obtain. So plenty of things for people to do vis-a-vis 29p. Okay. Now, maybe I should say something about why it is unusual. I mentioned about the outbursts, and in the papers I've published with the assistance of a number of other amateurs as well, one of the things that was shown and wasn't known explicitly before was the fact that the outbursts are explosive in nature, right? What I mean by that is that they happen very suddenly within a matter of seconds or minutes, the event that starts them. And that's not really the same as a periodic comet that approaches close to the sun. We're used to Halley's Comet getting in close to the sun. And when a comet is very near to perihelion, the thermal stresses are at a maximum because it's having the highest dose of thermal radiation. And so sometimes a comet will appear to brighten by, say, half a magnitude or maybe a magnitude. And that's because there's been some localized outburst, increase in activity. Now, much of the activity of comets is caused by what we call jets, active jets. And people will have seen some of the pictures, especially Hubble Space Telescope images, where some of the jets can be seen. Hale-Bopp was a prime example. In fact, because the nucleus was spinning, you had a sort of Catherine wheel type effect as several jets produced a spiral trail. So a jet actually appears gradually. It builds up, reaches a maximum and then it gradually fades and dies away again. That's not an explosive outburst. It is an outburst, but usually they're not that intense. But 29p has virtually, not all of them, but virtually all of the outbursts look as though they happen within the space of a very short time. And to actually increase in brightness, sometimes they'll increase by a factor of 100 or more.
Wow.
Nucleus will brighten by a factor of 100, or it appear to. And what's happening is there's a crust on the surface, and at some point the heat of the sun causes the crust to fail. Now, the reason the sun's heat has a particularly strong effect on 29p is that the nucleus happens to be turning very, very slowly. Our Earth spins once every 24 hours, and that defines our day-night cycle. But on the nucleus of 29p, the day-night cycle lasts almost 2 months of our time. So you've got a 30-day long, well, it's about 28, 29-day long night, followed by a similar length of the day. And it's this prolonged daytime solar heating of the surface that stresses the crust and causes it to fail in places. So when that happens, where there's any pressure that's built up beneath the crust, then the pressure is released. And one of the hypotheses that I'm suggesting that explains it is that beneath the surface is actually reservoirs of liquid methane, largely liquid methane. So this is like a geyser. Think of Old Faithful in Yellowstone Park. Some people may have visited there. And that erupts and throws out boiling water, essentially, because it's got this chamber of superheated water, superheated steam below the ground in the rock. And what happens is if the pressure above the geyser is released, then the gas that's dissolved in the water becomes supersaturated, and some of that is water vapor and some is gas, nitrogen, oxygen, and that behaves then rather like a cork coming out of a champagne. So suddenly you get it frothing, and it shoots out and produces the eruption of a geyser. Well, comets haven't up until now been known to have an activity like that, but 29p is the first example, the only example, of a comet that appears to have a cryogeyser. So it has cryomagma, or a chamber where the liquid is liquid hydrocarbon, and it's loaded with gases like carbon monoxide and nitrogen and possibly oxygen. And when that crust is released, when it breaks, there's a fissure in the surface, you get this champagne cork effect. And so as the pressure drops, a large amount of gas comes out of the liquid. It appears as a fountain going out into the vacuum of space. So that's pretty dramatic.
Yeah, that's incredible.
I was going to say, Richard, so let me get this right. So what happens is when it goes into night, the comet goes into night effectively, the fissure just tends to glaze over as a thin cover of material until the sunlight gets on it the next day and releases under the pressure. Am I getting that right?
Yeah, you're right. In fact, unlike water in a geyser on the Earth, the hydrocarbons behave like wax when they freeze over. So although I talk about a liquid, as it cools, it gets thicker and thicker, and just like a wax, it sets. And wax is well known for being its adhesive properties, and it actually holds the crust together. So that's the hypothesis. Now, one of the things is I've analysed the observations, and there were something like 17,000 photometric observations that were made by amateurs in 12 years of the comet. And what we found is that nobody actually observed it increasing in brightness. virtually. There may have been one, possibly two, but nobody has ever, even to this day, ever followed an outburst rising from quiescence to maximum. So the reason why that is that it's very quick. So to be able to be there, you either see it before or after. To actually observe it, it only probably lasts about an hour, because what happens is, as the material is thrown into space, the heat of the sun evaporates everything, and it creates a coma cloud that expands, and it accelerates to 100 or 200 meters per second, and that then blows out. It's like an inflation, and it expands out into space. And 29P has been doing this, obviously, since it was first discovered in 1927, but there's some software where you can actually calculate the orbits of objects back in time. It's called Solex, and we use this to calculate when was the comet last close to the planet Jupiter, because that's maybe when something happened that changed its situation. And it got to within 0.3 AU of Jupiter in the year 1376. But since then, it's kept its distance. But even 0.3 AU is actually not very close at all. So we think that the comet has been outbursting for many centuries, in fact. And so it's because it's a very large object, it's able to do that without sort of running down or running out of volatiles. And if, in fact, when you calculate the amount of material that's coming off, it could actually go on for many more thousands of years than the exact it's doing. So what would be nice to do would be to see if 29P would be a target for a space probe in the future. Exactly when, I'm not sure, but I'm sure that at some point in time, somebody will want to go and visit the comet and go into orbit around it. Because it's a very large nucleus, the gravity on the comet is actually quite substantial. I think everybody remembers what happened to poor Philae when the lander bounced off the surface, and it bounced at about 0.5 meters per second. And if it had been going beyond 1 meter per second, or actually not very much more than it traveled, it would have gone back out into space and never returned. So it's because of the weak comet of the 67, weak gravity of the comet 67P, where the escape velocity was only about 1 meter per second.
So 29P should have enough gravity to hold something in orbit then, if they sent a probe there.
Yeah.
So it'd be far less complex a mission in that case, wouldn't it?
Yeah, they had a lot of trouble trying to hold the... well, they basically had to fly the craft around the nucleus. It wasn't really in orbit, except it was about 20
it's doing constant manoeuvres, wasn't it, going round and round.
But for 29P, you could be several thousand kilometers away and still maintain an orbit. In fact, you'd want to be several thousand kilometers away, because when it's having a big outburst, you wouldn't want to actually have the craft too close.
No, damage it, wouldn't it?
Yeah. So I've spoken to a few people, professionals, and Paul Weissman, he was of the opinion that it's rather too active to be able to send a probe. But when you think that those eruptions are throwing material beneath the surface out into space where you can analyze it, it's doing the job of a lander for you. It's actually excavating its own subsurface and presenting it for capture or analysis by a probe.
Yeah, with the right equipment on there, you could get a lot of information from that, couldn't you?
I think it'd be quite an exciting mission, because we know that it will outburst. You don't know when, you don't know how strong it's going to be, you don't know where it's going to come from, and we know the surface must be covered in a number of sources. It also shows, I haven't mentioned it yet, but it shows very strong seasonal effects. So just as the Earth has the 4 seasons, well, a comet, if its rotational axis, the spin axis, is tilted like the Earth's, and it too will have 4 seasons. And it looks as though the tilt on the nucleus is more than that of the Earth, so the seasons are that much more pronounced.
Right.
So you can imagine that the northern pole or the south pole of the nucleus could maybe have a winter that lasts for several years, because the orbital period of the comet is around about 15 years compared to 1 year for the Earth. So the seasons last about 4 years in Earth year terms. And at the moment we've entered a new season, and it's not the most active time of the orbit. That was around about 2008 and 2010. So in another 15 years after that, in 2023 and so a few years after, we can expect particularly strong outbursts. But at the moment it's gone into a different phase of behavior. But it's still outbursting several times already this year. And for observers, it's a particularly useful object, because unlike a comet which only reaches perihelion every few years, we actually can observe this comet as opposition every year, just as though it was a planet. And so we have a good coverage for something like 10 months at a time. We can keep close to the time. I can report that, well, typically I said that it might take a couple of months between outbursts, but I can report that in the last few weeks we've had 3 outbursts in the space of 10 days.
Wow.
But they've all been what I call mini outbursts. So only by watching it very carefully with larger telescopes, particularly, although an 8 centimeter was actually used by a French chap called Jean-François Soulier. He's my main collaborator in terms of providing observations of 29P, although anybody, as I said earlier, anybody is welcome to observe. He's a very dedicated observer, and recently he set up a telescope in Haute-Provence in the south of France, which is dedicated to observing just this one comet. So whenever it's clear, the telescope is used and trained on the comet to check what's happening. And only about a week ago, less than a week ago, he reported something like a 30% increase in brightness. And well, you know, with a 20 centimeter telescope, now people might say, well, that's not necessarily real. But it happened that I was using a 2 meter telescope on Hawaii a couple of days each night, and I was able to confirm that in fact there was an outburst which was suspected by Jean-François, and you could see that the very centre close into the nucleus actually became quite a lot brighter. It used a very small aperture to measure the brightness of the nucleus, and it was one of these so-called mini outbursts, and there have been 3 in the last 10 days, and that's another fascinating aspect of this particular creature that's out there in space.
Is the coma quite stable apart from the outburst, and in between? Does it tend to, because if there's constantly outbursting but not kind of moving in and out in relation to the sun, does that mean the coma just gets bigger and bigger and bigger each time there's an outburst?
Yeah.
Or
Have a think. It's quite interesting if you think. I haven't mentioned it, but the escape velocity is a lot more than from Comet 67P. So to escape from the nucleus, material's got to be thrown off at a speed of more than 20 meters per second, right? Okay?
Yeah.
So what happens is with an outburst is, if you could be up close to it and to watch it, what I would expect is that you see this cloud of expanding dust and gas. It gets bigger and bigger and bigger and just keeps traveling out into space. There's nothing to stop it. But the material that was going more slowly, that actually at some point stops expanding and it starts falling back onto the nucleus. So what happens is, after a few days, the region around closer to the nucleus actually clears, because all the material rains back down onto the surface. Excuse me, it's 11 p.m.
I was going to say, Richard, in regards to people providing observations and stuff, is there any particular format you want to see them in? And for image, we know we discussed fixed images, definitely necessary.
Yeah, that's right.
But are you looking for ICQ format observations to be submitted?
No, not at all. Astrometrica, for example, will produce your results in standard format, not the full ICQ, because we're really only interested in the magnitude of the comet. We're not interested in the position. The orbit's quite well known. But we'd like people to measure the magnitude if they could. And one of the settings in Astrometrica is to express the magnitude to 2 decimal places instead of 1 decimal place. So instead of saying 15.7, it would be maybe 15.73. That gives us a little bit extra precision.
Okay.
And that's one of the settings, as I say, in Astrometrica. But I believe that normally, if you want to submit to the Command Center, you actually have to submit that with 1 decimal place. So if you submit it with 2, you get it rejected. That's how it used to be a year or so ago.
Right.
So what people do is that I archive sort of more precise photometry, and people would need to just remeasure with the setting for 2 decimal places on the magnitude. So that's the first format change. But I'm very happy to correspond with people. You could use an email address which is arps@britastro.org, ARPS. That's the asteroid and planet section.
Okay.
At britastro.org, and I could give people more detail. But in terms of the star catalogues we use, we have standardized on what's called the OCAC4 catalog. And the reason for that is that it's a particularly good one photometrically. It's good astrometrically as well, very good. But what they did recently in OCAC4 is they took the AAVSO's photometric catalogue, which is called APAS, and they combined it with the OCAC3 catalogue. So it has a very good, accurate catalogue for photometry. OCAC4 is the one to use. No other one. But I won't bore people with details on that if people want to.
Well, what I'll suggest then is when I'm doing the show notes up, Richard, if you can PM all that information to me, I can get that into the notes so it's there in black and white as well.
Yeah, I should mention that there is one very important setting, and that is the size of the. When you measure brightness of the comet, you have to use a circular aperture. You can use a square box to isolate that part of the image, and then the software adds up all of the intensity in the cometary coma and then subtracts off the background sky. So the actual brightness, the actual magnitude you get depends on how big an aperture you measure with. And so we've standardized on an aperture. It's circular. Generally, we use circular apertures. The diameter of the aperture is so many arc seconds projected on the sky, you see. So it's not the number of pixels, it's actually the number of arc seconds, how big the angular dimension is of the aperture on the sky. And it's a strange number. It's something like 11.3 arc seconds diameter. It's that odd number because that equates to if you were using a square box 10 arc seconds by 10 arc seconds. Any of the early photometry that was done in recent years was done using software called Focus, Spanish software, which measures cometry using square boxes. And we decided we wanted to keep to the same standard as Focus. And so instead of the 10 by 10 box, we use an 11.3 arc second diameter aperture. That's the nominal size.
Yeah.
So
I was going to say I've been playing with Focus myself recently, and it's a very useful piece of software.
Yeah. Yeah. I was saying to Mary that that if you were up close to an outburst, you'd see this expanding cloud. But if you waited a few days, the cloud would gradually expand out, but the area close to the nucleus would all clear because material would rain back down onto the nucleus. So, a space probe could actually sit there. It would see an outburst happen. It would have something like 12 hours notice before, maybe several hours notice before the material actually hit the spacecraft. So they could have shutters, or the spacecraft would automatically turn and present a shield or whatever, or it could collect the material as it came out, and then it would turn back after the outburst had finished and look to see what happened to the nucleus. So it would be quite exciting space mission if things like that were happening.
Yes, particularly with the success of Juno and its new rocket, the new engine they used, which is made by the UK as well, which is even more brilliant. They could certainly manoeuvre once they're at 29p a lot more than, say, Rosetta can today.
Yeah. So I mentioned it's very close to Jupiter in its orbit. It's only about a 1 AU. It gets typically about 1 AU from Jupiter. So it's a similar duration mission. You'd take maybe 5 or 6, 7 years to get there, and you could quite easily go into orbit. As to putting a lander on, I was talking to one or two professionals, and they were saying that if and when they do the next mission to a comet, they wouldn't actually put a lander on in one place. They do something quite different. They might actually have something that rovers across the surface, or it would hop across the surface. So it would be, you didn't need much of a thrust to actually lift the spacecraft off the nucleus and then move it sideways and bring it back down. So it would be you could explore the entire surface of 29P. And remember, it's a very big comet.
Yeah.
One factoid that I noticed recently that I picked up. You know that the Pluto New Horizons spacecraft is heading off to it's past Pluto now, of course, and it's now going to be redirected towards a trans-Neptunian object. Well, they've identified the object, and the trajectory has been set. And it'll get there in a few years' time. I think it gets January the 1st, is it 2019?
Right.
Anyway, that object is called 2014 MU89, and its actual size is somewhere between 25 and 40 kilometers across. So it's quite a bit smaller than Comet 29P. So there again, here we have a possible trans-Neptunian object, but it's a representative of it, which is much easier to get to, and you can easily go into orbit around it, and they could study it at length if they were to target a mission there in the near future. So there's going to be a big meeting in Pasadena in October. There's a joint planetary science meeting. It's a joint meeting of the Europeans and the Americans. It's been organised by the Division of Planetary Science at the American Astronomical Society, and all the European astronomers were invited. So it'd be a good forum to test out some ideas on where to next in terms of comet mission.
Definitely.
Not only that, the fact that we've had the experience of Rosetta, we can use the information from New Horizons. We can even use the experiences from Juno to actually see what is now possible. And as you point out, Richard, it is relatively close in space to us, and the fact that if the comet did go very active, the spacecraft could either react on its own, or mission control is in a much better place to do something.
Mm, mm. Yeah, I hadn't quite thought of it like that. In fact, 29p has got a mixture of all those three missions, hasn't it? It's got,
Yeah.
with the learning curve we've had with 67p is next time a mission to a comet is organised, we've learned a great deal having visited 67p. And then again, Pluto, of course, but that was a transient passage as the spacecraft flew by. So, and now with Juno, people's attention is focused on the sort of intermediate region of the solar system, somewhere that's relatively easy to get to. So 29p has got everything going for it. It's a mixture of all those three missions in a way.
Yeah, and the technology is now relatively proven as it can ever be. We have had hit and misses with certain planetary probes, but when it comes to going to a comet, or when it comes to going to the far reaches of the solar system, we've been very, very successful. Jupiter has never given us the trouble Mars and Venus has given when we've been trying to send space probes there. And with even going back to the Voyager and Pioneer probes, that also has contributed to our skill base in sending out these new missions. So as sending a mission to 29p would be a lot easier today than say 10 or 15 years ago.
Yeah, it'd be interesting to see what the people at Jet Propulsion Laboratory, what they do is they look at these orbits and they work out the best way of getting to places, and that might mean delaying the launch to a certain date where there's a favourable orientation of the target, call it that, relative to the Earth. And obviously the Grand Tour, the Voyager spacecraft, was a prime example of that being put into practice. But nowadays they actually slingshot probes by first of all targeting them to pass either close to Mars or the Earth itself, or even Venus, as a way of getting out to the further out to reaches of the solar system more quickly.
It's a very cheap on the fuel issue as well. You can use gravity as your assistance in getting somewhere. It's a little bit longer time-wise, but that gives you the time you need to get your ground crew, your science teams up running everything. You can practice, and when you actually get there, you've prepared, you've probably done who knows how many simulations of what can go wrong at the target. And I'm pretty sure they must have done that on Rosetta, running up to the actual rendezvous itself. So we in terms of learning, we have done an awful lot. As Patrick Moore pointed out, going back to the late 70s, we've gone from the first aircraft to putting a man on the moon in the same century.
Yeah.
So we've gone from sending space probes to beyond the solar system now, to actually sending a mission, a successful mission. Even with the loss of Philae in the end, it's still a success. We proved we can do it, and that will allow us to do some really spectacular science at places like 29p.
Yeah. So only we could give it a better name instead of 29p or pronounced Rosman Bachman. So Americans like to call it SW1 because Rosman and Bachman was the first comet discovered by them, but they discovered two more. There's Schwarzman Bachman 2 and also 3. The latter one is also known as 73p, and that's been fragmenting the last couple of perihelion passages. So it's gradually falling apart. But there's no danger that 29p will fall apart because it's so massive.
Exactly.
It's enormous, and it's far from the sun, so it's in a very stable environment.
Which is nice for us actually, because we don't really have to worry about it doing a Comet Ison on us.
No.
No. And also when they originally with Rosetta they were going to go to Comet at 6p, and unfortunately the Ariane spacecraft had a failure, and they decided not to risk it. So in the end, they had to change through another target, and 67P was chosen. And that another story is the Deep Impact spacecraft. They observed 9P, and Stardust observed 81P. I think it was the Stardust mission. That probe was redirected towards 9P and observed 9P, but there was an attempt to send one of the probes to Comet 85P, which is called Comet Burton. But it turned out between when it was first observed for a few years and when they decided they wanted to send one of the probes to it, nobody could find the comet again. They used the 8-meter telescopes at the European Southern Observatory in Chile, and they failed to find 85P and gave up and had to retarget another object. So the advantage of 29P is it's not going to go away, and it's like visiting a small planet with, and you won't have the problem that Juno has of the very intense radio emission and high energy particles that the strong magnetic field of Jupiter cause for the probe. As I say, it's relatively benign out by the environment of 29P. So the job, I think, for amateurs in the next couple of years is to keep a close watch, CometWatch on 29P, because the more we can demonstrate its unusual behaviour, the more interesting a target it will be for professionals.
And not only that, the fact that we have this huge amount of data handy, we know exactly where it's going to be, we know what it's doing, so the hazard issues can be mitigated very successfully and very easily.
Oh yeah.
And
can I mention? There's another fascinating aspect which was also found in papers. One is that when you get an outburst, okay, you might have waited a couple of months for it, but there's a high probability that after you've had an outburst, you have another one or even two that follow on from it. And what this is sort of triggering. When you get an outburst, it seems to trigger subsequent outbursts. So remember I said about material falling back? Well, the hypothesis I've put forward is that what happens is the dark cometary dust rains back onto the surface, and where you've got a crust where you've had pressure building up beneath it and a waxy sealant has kept it intact. Well, the waxy material is relatively white in colour. It's what we call albedo, whereas the cometary dust is very, very dark. So when the dust coats the waxy heat of the sun is absorbed more readily by the wax, and it softens, and that's why one outburst can trigger off other sources of outbursts. Now, you might think that's a new idea, but actually Whipple's paper in 1980, one of the things he found, as he says in his paper, is that he found that there was an unusually common occurrence that when you had an outburst, you had another one about 5 days later. And this is really a manifestation of this self-triggering of outbursts. When you get one outburst, it actually causes a second event to take place. That's something that's really intriguing, and it would be another reason why a space probe would be a good objective, because it would obviously resolve that mystery whether in fact that was a mechanism that was going on the surface of the nucleus. So Fred Whipple was ahead of his time really, but unfortunately he wasn't working with all the data that the amateurs have produced, which has allowed me at least to get a handle on what's going on 29B. There's a lot more that's still to be done, and I think the main thing is for amateurs to get out and observe Partly.
What kind of telescope aperture would somebody need to pick up a comet that's because obviously a lot of people are going to struggle visually to find a Mag 13 comet. I'm presuming
No,
you need a moderate telescope.
no. I think. Remember, the only benefit I think of a visual observer would be just to check whether or not an outburst had just happened. Um, so it's it's 1,000 to 1 sort of probability that if you're just happening that evening to be watching, you'll be the one to actually discover it outburst. But that's actually a better odds than discovering a comet from scratch anyway.
Definitely.
If you want to try and discover a comet and have your name imprinted on it, christened Comet Spicer, then you've really got to be a dedicated observer, and you've got to observe for thousands of hours, because the competition now is much more serious. Professional
sky
surveys
surveys
picking
get
up too soon.
yeah.
So, but maybe 1 in 1,000 times you observe 29p, you'll catch it in outburst before anyone else.
So
Maybe
if you've got a clear night, it's worth just swinging round to there and just taking a picture on the off chance.
Actually, I'd say the chance is probably between 1 in 100 and 1 in 1,000. So it's not like discovering a comet. You've got a good chance of spotting it. But,
So is it actually visible when it isn't in outburst?
No, it won't be visible visually. It's around about 15th to 16th. I know in the announcement at the start of the program, we said that is one of the comets visible. And it was quoted as Mag 13 question mark. Well, it's 13 if it's had an outburst in say the last week or so. But if it's quiescent, it'll be Mag 15 or so.
Okay.
The nucleus could be even 16 or 17.
However,
so you do need a CCD or a DSLR, preferably a CCD camera.
yeah, I was about to say that. However, if you've got a CCD and processing programs, you have a very good chance of getting it. In fact, if you're using even a remote telescope, most of them now will give you the FITS files if you ask for them. So yes, process it at home. Send the files in to yourself, because all of them it's all valuable data.
Yeah, we had a bit of fun today because one of the observers seemed to be seeing 29p getting brighter earlier today, and so over a period of about 8 hours during the early part of today, it's the where are we? The 10th, and so I tried to use the 2 meter, but the weather was too humid and couldn't observe it. So I used the remote telescopes at iTelescope in Siding Spring, which is a very good facility. There's a large number of telescopes you can sign on to. You do have to pay, obviously, for time. But I was able to observe it and find that it wasn't starting an outburst. What had happened is the comet had moved in front of the field star, 15th magnitude star, and it was looking as though the comet was getting brighter, but it was just the fact there was a background star that was superimposed. So the observer was right to signal the fact, but in fact there was a mundane explanation for it all, unfortunately. But we have, as I say, we've had 3 mini outbursts in the last 10 days or so, and this could be very much an example of one outburst triggering the other 2. It's in with what Fred Ripple found all those years ago.
So basically, we really do need to keep watching it, recording it, and sending it in.
Yeah, like if people want to get their feet wet, they can just take a long exposure, a couple of 2 or 3 minute exposure, or stack a number of exposures, and just get a rough measure of the magnitude. It doesn't have to be that accurate. That will be good enough to know whether it's starting an outburst. And anyway, even if we don't know it's starting an outburst, somebody a few hours later will probably catch it in outburst, and the observation the person made first of all would set a limit on when the time of that outburst happened. So you don't actually, so long as you need to be able to measure these things photometrically very accurately to have contributed, and you can report your result to the Minor Planet Center in a normal way. But if you could get your feet wet doing that, and then if you found that was interesting enough, you could then move on to then try to do the photometry using the standard procedure. And I'd be very happy to help anyone who aspired to do that.
I think my favourite brand of remote telescope is going to be getting a lot of work from me soon. I keep submitting imaging sessions for Comet, and I keep getting clouded out. However, I do have an iTelescope membership as well, and I think over the years I have an unholy amount of points that I haven't used up yet.
Yeah. It's very philanthropic of you to support these telescope farms. They're doing a great service really for the amateur, and some professionals are using them now. I must say it was a bit of a struggle today to get that confirmatory image of 29p, because the wind speed down at Siding Spring was a bit too high, and the roof was opening and closing. So sometimes you have to. It's quite good fun, You have to sort of chase your object. Sometimes it's because there's clouds coming over, and you can just grab an image between in a clear patch as it goes over. It's like as though you've got your telescope in your backyard and you're using it yourself. It's a great game, and a lot of people actually do use iTelescope, and some of the others like Sierra Stars Observatory to do just that. So that's a fun thing you can do while it's cloudy back home.
Absolutely. I know all about clouds at the moment. In fact, it's also now started to rain. I'm glad I left the telescope in.
Yeah, I'm rebuilding my telescope. I decided I'm going to make it out of the whole enclosure out of aluminium and stainless steel, because I'm fed up of either the water getting in or the wood going on. So I'm going to try and enclose my C11, my Celestron 11, with an aluminium enclosure, and operate it from the cottage remote.
Yes, that's one of my goals. So I'm going to get my 10-inch Deuterium back up and running. Just run an Ethernet cable out to it.
Yeah.
I bought a very long USB cable for the imager. So it's just a case of just making the necessary holes in the brickwork to run cables through. Now I'm going to ask you if you could give a list of specifics, so that when people are trying to image and do observations for you, they know exactly what you need. Is that possible?
Yeah. I'll just run through it very quickly and slowly. First thing is you can observe without a filter. If you don't use a filter, that's quite good actually, because the response of the camera. This is a CCD camera, not a DSLR.
Yeah.
I wouldn't use a DSLR for this project. I would use the CCD. You don't need a filter, but if you've got one and you've got a reasonably large telescope, then just the red filter, but not the red filter out of an RGB set. It'd be better to use a luminance filter, clear filter, than to use the red from an RGB set. You'd have to use a red photometric red filter, which is sometimes called a filter. So that's the first thing. So that opens it up to lots of people, observing without a filter. You need to, if you can, get as much signal to noise on the target. So you've obviously got to be able to track the telescope while the image is being exposed. But if you can't actually track and keep the object still, or the stars as point sources, just keep your exposure time short, maybe 30 seconds or 60 seconds, and then stack a number of images. That will overcome the problem of being able to track accurately. So that's the next. The comet is actually very far south of the celestial equator at the moment. It's just last year it reached its furthest south, and it's on its way back north at the moment. So this year the comet is around minus 25 degrees declination, which puts it out of reach for, say, UK people. But France, it's possible to observe it from France if you've got a good southern horizon, low horizon. But the good news is that come next year, it's much further north. And from then on, for the next 10 years or so, it'll be very readily accessible for, well, certainly for people around the globe. Certainly for the next 5 years, it'll be accessible from wherever you are on planet Earth. So it's a good target to start to follow up starting now, because it's moving also out of the Milky Way, the region in Sagittarius, and will be moving into relatively clear sky, which will make observations and photometry a lot easier to do. So what else? Telescopes of about 25 centimeters or larger really are preferred, and the larger the better. So that's that. Well, good luck, I suppose. The details of how you analyse the images, but I think in terms of actually capturing the images, that's all you need to know.
Great. Now, what I'm going to suggest then is I'll be doing the show notes shortly. Anything you can send me, Richard, I'll gladly put in the show notes. Please, everybody, if you are listening to the show, go read the show notes. The links are there, and there'll be extra information if you do decide to get involved in this project.
Yeah, it'd be good to put the BAA journal articles that Richard's written as well, because they're really good, really informative, and it'd be quite handy to have those for people to have a look through as well.
Yeah, that's a good idea, yeah. A few PDFs we can put up. They're only a couple of pages at most, so
so
quite digestible. But one of the things that we'll be posting on the Comet Section website soon is the full details, the procedure for analysing images once you've got them.
Brilliant.
That'd be really helpful.
And I think that's going to be an important thing. So we can put the link to that, and people can get to that to get the full details. Yeah.
That's always the first link I always put on the show notes, the BAA Comet section.
Yeah.
Well, we use it all the time, so it's very important that people can actually access it and see what we're talking about.
Yeah. I've also got to put an article, I think, into the newsletter, call it that, or it's a publication the Comet Section produces. It's called The Comet's Tale. That's the name of it, spelled Tale. And Janice is our editor-in-chief. So I promised her I'll send up an article, and I think the best one is really this business of encouraging people to start observing, because it's very timely at the moment. The comet's starting to move northwards. It'd be accessible for all observers, and it'd be good to get that information, which will convince the professional community that the 29p is well worth the target for space mission. I should add that guess how many times the Hubble Space Telescope's been used to observe it? Just twice.
Yeah, I was going to say, isn't that many? I know that it saw the Weasley impact on Jupiter. It was retargeted, even though it wasn't fully fledged again for that. But getting something like that would be very helpful. One thing I'm going to suggest is that if you have any observing alerts you want to put out, let us know. I have spoken to the program directors at astronomy.fm. They have said just give us 24 hours notice, we will get it on the air.
Oh, good. Yeah, okay. Well, I'll just say that we wouldn't want to give people false alerts.
Yeah.
We wouldn't want to suggests there's something happening when there's very little to see. So anything that's a mini outburst wouldn't qualify for an alert, because my definition of a mini outburst is it's less than 1 magnitude, and that really is pretty insignificant, certainly from a visual observer, because it typically might only reach 15th mag.
Yeah.
But anything which is a significant outburst, say 2, 3, 4, 5 magnitude, then that's worthy of an alert.
Yeah.
And
Yeah, we can certainly do that. That's not a problem.
yeah, I'll just look. When was the last one? It was. The last significant one, it reached about magnitude 1.5, and that was about a month ago. So, in a month's time, maybe 2 months' time, we might very well have another.
Well, please do contact me, Richard, because they've said they need 24-hour notice. They can get anything we need out.
Yeah, we fortunately, I mentioned about our contacts with professionals and have been improving year on year. Well, there's a joint project with a couple of UK professionals, Alan Fitzsimmons and Colin Snodgrass, and they've got what's called target of opportunity time on the Liverpool telescope. That when I flag an outburst, they can override whatever program is being conducted on that telescope, which is on La Palma, and they're going to turn it onto 29p and take spectra of the outburst. So that arrangement began on July the 1st. So there's another reason why amateurs should try and spot the outbursts, because if they do, they'll be texting the professionals to trigger that target of opportunity spectroscopy from La Palma. So this is the first time that's ever happened, ever been arranged. So if you spot the outburst, then and it's confirmed, then we'll trigger some large telescopes to observe it.
Now, you said about spectroscopy. If anybody wants to have a go themselves, because I know there are a few amateurs out there who are set up for it, and who would probably be quite interested as well.
Yeah, if it were to go into outbursts and reach, say, 11th magnitude, which is what it has done from time to time, then that would be a really good target even for the amateur spectroscopist. Because when it first goes into outburst, all of the light is concentrated very close to the nucleus, and so the first thing you see is a new star in the position of the comet. Essentially, it's perfectly stellar. You catch it within 12 hours of an outburst, it'll only look like a bright star. So, but then as the hours pass by and the next few days, the coma will expand and you'll see it appear. So, if you've never seen that happen, then that's something worth witnessing yourself visually. I haven't seen it. I'll get my telescope up and running again, and hopefully then we'll have a nice bright outburst, and everybody can look. Yeah.
Yeah.
Is that? Do you think there's one or two people who take an interest in 29?
Well, given how we've had reactions to shows and when we put out requests for observation and stuff, I think we have a good audience out there who will be interested. I can think of a few people who are certainly think names like Tony Angel spring to mind. He's based in Spain, so he's definitely got a good crack of the whip. If your person who's working with is in Provence, so therefore I thought Tony would have had a good chance from Spain.
Yeah, that's right.
Hey, Tony,
and I should add that it reaches opposition in 2 days' time. So basically, we'll be on the meridian, the south meridian, at its highest point at 0 hours UT from the UK, roughly. It'd be, so local midnight.
Yeah.
The comet will be due south, and it's highest in the sky. So even if you are in the UK, you know, I haven't had any observations yet from the UK, but as I say, it's reaching opposition, which will be 1 a.m. local time, which is summer time, and you know, it would be about maybe 10 or 15 degrees above the horizon. So observe with an R filter, and that would be a valuable observation. Yeah.
In fact, I've had a few thoughts. There's some of the past guests on the show based in Australia who do have a very good scopes and CCD setups. I might put the word out and see if they can help us as well.
Yeah. I'm on a fast track to the Australians, partly because my son lives in Melbourne, and I've actually produced an article for the magazine of the Astronomical Society of Victoria, which is the largest astronomical society in Australia, and they have a comet section, and so yeah, there's one or two people already galvanised into action, keeping a watch from Australia, but Australia and New Zealand, the Antipodes, they're quite well placed, because they're about 12 hours difference from us, and that's useful, to have global coverage. And New Zealand in particular is we're able to pick it up quite early on. So in theory, we could have 24-hour coverage.
Yeah, I was thinking of particularly people like Jenny and Michael. They're nice remote areas, and they have pristine skies pretty much. So
yeah,
I'm definitely going to send out a few messages tonight and see if they're interested.
Okay.
Neil,
Let's see if they want anyone to come and visit them on holiday for a week.
I was going to say, Neil, Mary, any other questions?
Yeah, so in Swan Hill. Yeah.
Yeah, that's the crew I was thinking about, actually, Richard, the Swan Hill guys, because we had them on the show recently, and that was quite good fun, because one of them, I think it was Jenny, was actually observing and taking part in the show from a telescope.
Yeah, that's true, yeah.
It's good. I don't think I have any more questions, but Neil, you have not given you a chance to speak yet.
I know. I've been sitting here mesmerised. I'm loving this subject. I love this comet. I really do. I think I've said many times before we should have got a probe there, but
yeah.
And I just wondered, Richard, has it ever? Just one quick question: has it ever shown a tail at all, or has it just been a diffuse coma? There's never been a tail.
No, strictly speaking, there's never been a tail on 29P. What you do get, though, I haven't mentioned, is that, remember I said they're explosive, the outbursts?
Yeah.
When they go off, they therefore go off in a preferential direction, a bit like a geyser. And so what we see after a day or two, we often see the outburst is actually preferentially going in one direction. And when you get a really big outburst, what's really odd is you can get really strange patterns. So you get several preferred directions. So really strong outbursts are very unusual, and have an unusual morphology. Strangely enough, of the 2 times that the Hubble Space Telescope was used, the first time back in 1996, they wanted UV spectroscopy, and they took some images as well for reference. And unbeknown to them, the comet had gone into one of its really strong outbursts just about 10 hours before the Hubble was used. And so the very first images were saturated because it was so bright. But I was able, although no paper was published, I was able to analyse, because the images are freely accessible on the web, and it turned out that when you looked at these outflows coming from the nucleus, you had this strange sort of twofold symmetry, as though it was spraying out in 2 opposite directions. And since then we've seen there was one particularly strong outburst where instead you had 4 outflows, like an Einstein cross, coming out in 4 opposite opposed directions. And so although it doesn't have a tail, if you've got a larger telescope and good seeing, it's very worthwhile to see if you can see the structure in the coma a day or two after outburst. So that's what we've been finding that amateurs have been doing in recent years, is where they won't discover the outburst. Once they know there's an outburst, they pile in and they get some good images, and we are able to look at what we call the morphology of the coma. And I should say that I haven't even started to try to analyse the morphology of the coma of 29P. So that's an area for future investigation in terms of the analysis. And what we need there is, more images of the developing coma, because with CCDs, amateurs can get some valuable stuff, and then maybe one or two of us can try and pick our wits against the observation and see whether we can decipher where, what these patterns mean in terms of the nucleus, and where these sources of outbursts are and things like that, and what the tilt of the nucleus is, all of that. The more we can do, get those observations, the more we can say in the future, and the more, I think, be a convincing case for targeting the space probe. And we do, people who send space probes, they need to have information about the nature of their target. They're not prepared to send probes unless they can be fairly sure that they can design the instrumentation on board to take advantage of what is known about the target. So the more we can get, the more likely, I think, it will be targeted. Yeah. So I think that. I rest my case, sir, and the jury is out. So we'll see.
Great, thank you very much, Richard. It was really great having you on the show, and you have given us quite a lot for thought. And if you are listening to the show, please do get in contact. Contact Richard, contact ourselves here at the Sky Guides, and we'll get everything sorted out, and we'll pass the results on, because I'm sure that there is a lot we can do. And if nothing else, we will actually not only perhaps bolster the professional amateur relationship, we may even finally get a space probe going to something that's close to home.
Yep.
So I guess all that remains now, this has been we've been going for over 1.5 hours, so we've done quite well tonight.
It's gone so fast. It's been absolutely fascinating.
Good.
So, as I say, this remains, I think, for all of us to say goodnight, and we look forward to hearing from you, the listeners, seeing your images, and seeing what goes on. And Richard, if you can get us links to the articles and stuff, I'll get everything, like I said, into the show notes, so that it's all there for those who wish to help us out. So, from me, it's good night.
Good night from me.
And good night from me too.
And good night from here in Dorset. Goodbye.
And we'll see you all next month.